You ever stop and think about what's really going on inside your phone charger? It feels like magic, right? But it's not. It's all thanks to a tiny, incredibly important electronic component that might just be the biggest unsung hero in your daily life. Today, we're going to break down the diode.
All right, so here's the game plan. We'll start with the simple rule that makes it all work, this idea of a one-way street. Then, we'll peek inside the electronic gate itself. After that, we'll uncover its most important job, meet some of its specialized cousins, and finally, really understand why this tiny device is such a massive deal.
So, first things first, we've got to get a handle on the fundamental principle here. And it's a concept so simple, it's kind of mind-blowing that it powers nearly every piece of electronics you own.
So, let me start with a little riddle. What in the world do your phone charger, the alternator in your car, and a simple little LED light all have in common? They seem totally different, but they all depend on the exact same electronic trick to even work.
And that trick is all thanks to the diode. At its heart, a diode is basically a bouncer for electricity. It lets current flow through in one direction, no problem. But if that current tries to turn around and come back, nope, the door is closed.
The easiest way to wrap your head around this is to picture a one-way street, right? Cars can only go in one direction. Or if you've ever dealt with plumbing, it's just like a check valve. Water can flow out, but it can't flow back in. This simple rule, well, it's everything.
Okay, but how? How does this tiny component actually enforce that one-way only rule? I mean, what's really going on in there? Well, to find out, we have to zoom way in.
So, a standard diode has two connections, or terminals. We call the positive side the anode, and the negative side the cathode. And see that symbol used in circuit diagrams? The little triangle literally points like a one-way sign, showing the only direction that current is allowed to go. Super handy.
Now, the real magic happens at a microscopic level in something called a p-n junction. This is where two types of specially treated material, a p-type for positive and an n-type for negative, are fused together. And right where they meet, this natural barrier forms. It's called the depletion region, and that is our electronic gatekeeper.
So if we've got a gate, how do we open and close it? It all comes down to which way you push the electricity. If you apply voltage in the correct direction, we call that forward bias, that barrier just shrinks away and the gate swings wide open. But if you try to push electricity the wrong way, that's reverse bias, the barrier actually gets even wider, slamming the gate shut.
And you know what? It doesn't even take much. Just a tiny little nudge of voltage in the right direction, about 0.7 volts for a typical silicon diode, is enough to get past the gatekeeper. The gate shrinks to nothing and boom, current flows right on through, free and easy.
Now we get to the diode's most critical role in our daily lives, taming the wild electricity that comes pouring out of your wall socket.
So here's the problem. The power in our homes is alternating current, or AC. That means it's constantly switching direction, sloshing back and forth 60 times a second. Now, your phone, your laptop, your TV, they can't use that. They need a steady, one-way flow to work properly.
And the solution to this problem has a name: rectification. It's really just the official term for turning that chaotic, two-way AC power into the smooth, one-way direct current, or DC, that our electronics are thirsty for.
So how does the diode pull this off? It's actually beautifully simple. Since it's a one-way street, it just blocks the entire half of the current that's trying to go the wrong way. It just chops it right off. What you're left with is a bumpy, pulsating current, sure, but, and this is the most important part, it's only flowing in one direction. That's the first giant leap toward creating the clean power your devices need.
But the story doesn't end there. Once engineers perfected this one-way gate, they got really creative and built a whole family of specialized diodes.
You definitely know the first one. LEDs. They're just diodes designed to give off light when current passes through them. Then you have Zener diodes, which cleverly use their gate-closed state to regulate voltage. Photodiodes do the opposite of LEDs. They turn light into current. And Schottky diodes are the sprinters of the family, built for incredibly fast switching.
So let's bring it all home. After seeing what it is and what it does, we can finally appreciate why this tiny electronic gate is so incredibly important. This quote really just says it all. You can't get much more fundamental than this. The ability to control the direction of flow is one of the absolute bedrock principles of modern electronics. Without it, almost nothing else works.
And the scale of this is just hard to comprehend. Over 1 trillion semiconductors, which includes countless diodes, are made every single year. That's more than 100 for every single person on Earth, every year. They are, quite literally, everywhere.
So the next time you plug in your phone, remember what's happening inside that little block. A tiny component is enforcing a simple rule, a one-way street for electricity. And that simple rule, repeated trillions of times over, is what makes our entire complex digital world possible.
It really makes you wonder, doesn't it? What other simple, fundamental rules are out there, hiding in plain sight, quietly building the complex and amazing world all around us?